I welcome to you all to the Computer Organization and Architecture lecture, and let us start with the concept of Von-Neumann architecture. So in the computer organization and architecture, there are two main concepts. One is the Von-Neumann architecture concept, another is the Howard architecture. So we can start with this Von-Neumann architecture. This architecture was developed by renowned scientist, mathematician John Von-Neumann in 1945. Okay, and mainly this architecture is based on, as it is written here, on the concept of instruction data and program data, which two data are stored in the same memory location. That is the primary concept of this Von-Neumann architecture. Okay, so you can see here in the right hand side of the diagram that we have this central processing unit. In this central processing unit you have the control unit and the arithmetic logic unit. Okay, and along with that you have the memory unit, and there are two devices. One is the input device, another is the output device. So as the concept shows that instruction data and program data, both the data are stored in this memory unit. Okay, this is the primary concept of Von-Neumann architecture. Now this is the machine of the Von-Neumann architecture, which we have seen in normal different books and different references, and we can find it here that this architecture is implemented in this machine. Now coming to the Von-Neumann architecture, you can see it here that this is the arithmetic logic unit, ALU, and the second one is the program control unit. Okay, that is the control unit part, and this is the main memory, and this is both the input output device. So the direction is showing this line. These are basically how the data are used to be flowed from one unit to another unit. Now in this context, it is relevant to mention that there are various nomenclatures of this things, like what are the main blocks that are given here in this diagram. So you can see it here, there are different processor registers are there, and one of the major processor register is accumulator. So AC denotes it is the accumulator. So along with that MQ is the memory quotient. Okay, this is another form of data storage. So ALU, we know that in the ALU different types of arithmetic and logical operations that is used, and in the further chapters, like in module 2, you will able to understand how we can design the ALU. Okay, now MBR is the memory buffer register, memory buffer register, memory address register. There are various types of registers, those are present. So this is memory buffer register, where the data is basically stored here. Now in program control unit or control unit, you know there are different registers. Now this PC is the program counter. Okay, and this MAR is the memory address register. So there are two memory registers, important memory registers we will be learning here: memory buffer register and memory address register. Now IBR is the instruction buffer register, IR is the instruction register, and PC is the program counter. So here in this total diagram, you can see it here that whatever you are giving from the input output, and that is coming via this line, okay, that is going to the memory buffer register, and some processing is going to be happening here along with the along with this different types of registers, and whatever is the result, it is going output as the output to the output device if it is a normal. And related control unit signals, the control signals are basically generated whether it is a read signal or write signal. So if this is a register based operation, so the registers are residing here, it can just go to those registers and it can fetch the data from register, or it can store the data in the register. But if it is a memory operation, definitely we will be using some different types of control units like read signal, write signal, and depending on the read and write all those operations, that particular address is basically read, okay, and the data is fetched, or some data is stored here, like that. Some different types of operations are happening depending on the types of instruction. So if it is a register based instruction, that is if the instruction is containing, like if you have one instruction like add r1 comma r2, so we are not using any memory here, okay. So in that case we are only doing the addition operation using the CPU registers that are residing here, okay. So this is the structure of the Von-Neumann architecture, and what are the operations of various registers and buffers that we can see it here. That memory address register specifies the address for next read or write. So definitely whatever is the address that it is showing, it is the next address it is showing, okay. And memory address register is this, and memory buffer register contains the data. So it is basically containing the address of the next instruction, okay, which is to be read or write. And this memory buffer register contains, okay, the data itself, okay, whatever it is writing or receiving, those data from the memory, it is stored in the memory buffer register. Now program counter is a common register, so not a 8-bit register. We know that 8-bit is a 1 byte. So these program counters and all these types of register are basically 16-bit or 2-byte register. So that is the size of the program counter. And you know that this type of register stored the address of the next instruction, okay. So apart from that, there are other general purpose registers here like R1, R2 as we are telling here. And in case of 8085 microprocessor, there are a set of 8-bit register like B, C, D, E, H, L. Those are known set of general purpose registers, the CPU registers. We can find it here, okay. Now apart from this, we can see another thing like instruction register. It stores the instruction before decoding, and instruction decoder, it decodes the instruction before execution. So these two things I will come to the latter part of this lecture. And the ALU part, you know, arithmetic and logic unit, it can perform all the types of arithmetic operation, addition, subtraction, logical operation like XORing operation and all this. And control unit is basically used for sending or generating some signals, control signals, to execute some specific task. Now one important point I will mention here, that in the simplest form of this Von-Neumann, the instruction processing is going to happen using two steps. What are the main two steps? One step is the fetch operation, another is known as the execute operation, okay. So when we are going to this step by step process, there will be two steps. One is the fetch, another is the execute, okay. Another case we have the fetch, decode and execute. Now this cycle is known as the instruction cycle, okay. The process required for a single instruction is called the instruction cycle. So what are the steps that are there? Two steps. For the simple case, two steps are referred, like the first is the fetch cycle by fetch step, second is the execute. So if it is a start process, then fetch the next instruction and then you execute the instruction, until it is getting ended. This process is getting repeated, okay, one after another. So this is the way we can define the fetch execute cycle of the Von-Neumann architecture. Now you can see it here. There are various types of processor, like PDP-11 processor. You have one instruction. The instruction is add B, A. What is the meaning of this instruction add B, A? As you know that I have already told you previously that in the class that when we are writing this type of instruction add B, A and all, so what we are performing through this, we are adding two data. Okay, now in this case it is mentioned here this B and A, these two are memory location. So what will happen in that scenario? So these are not the two registers. Instead of that, this B and A are two memory locations. So definitely, what is the process of handling this type of instruction cycle? So you have to fetch the instruction. First you have to, this is the instruction, this add is the add B, A. B and A are not registered. These are the memory location. So you have to fetch this instruction first, and this read the contents. So to read operation, because this is not a register, so this is a memory and this is another memory. So you have to go to this particular location and you have to fetch whatever is the content in that particular memory location, and you have to go to this memory location as well as you have to fetch the content of this memory location, right? So these are supposed to memory, this is a one memory, and suppose this location is A, okay, and this location is suppose B. So this is suppose this is 7 hex and this is suppose 2 hex. These are the two things that you are happening. So the content will be 7 plus 2. So this is not the third step. Will be adding the contents of these two locations. You will be adding these two values and you are writing the result to the memory location A or B, whatever it is. So you are adding this two content and you are just putting the result in the location A. You may put the result in the B also. That is not so. In different books the conventions are different, but whatever may be the location, the process is like that. It is dealing with two memory access to initially to avail the content first 7 and 2, and then it is going to add, and whatever is the result it is going to store back to the memory. So the last step is not only the addition, so two memory read operation it is going to do here to fetch 7 and 2, and one addition operation is going to be held and one memory write operation is going to be held here. Okay, so if this is the typical type of thing, so what the instruction cycle will look like, you can understand from here. So the instruction cycle for this particular example, as you have seen previously, that all these types of memory operations are happening. So you can find it here that instruction address first calculation. Suppose you want to access memory location A. So which address you are going, whether it is a direct fetch operation or you have to add some value. Okay, so this is the first, you find out the address, then instruction, you particular instruction you are fetching the instruction, then you are operating on those things, okay, whatever is the operation. Then operand address calculation, this is the main address calculation, whatever is add B, A, that is an instruction, that instruction is stored in some address, right? So that particular instruction is calculated, address of the instruction is calculated. Then you are fetching that particular add b comma a instruction. Then you are decoding what is the meaning of add b comma a. Then b comma a, b and a are two operands. Oh, that is not the operand, that is the address. So you have to fetch those operands from those two different memory locations, and whatever the data 7 and 2 that you have seen in the last case, those two memory locations are separate, so definitely those two needs to be fetched out. So that is happening here. So you have to fetch the two things. So you first find out what is the address of A, what is the address of B. You go there, you fetch those operands 7 and 2 out of this, and you do the operation, that is the addition operation that you have to do. And then you operand address means the address of, here in this example it is the address of A, so you go to the address of A and store the value 9 here in that particular memory location. So this is the thing that we have seen. And there are different types of states, like instruction address calculation. It determines the address of the next instruction to be executed. Instruction fetch is one major operation when you are reading the instruction, like add b comma a is the total instruction and you are reading the instruction, and this whole instruction is stored in some memory location in the processor. Okay, so you have to read it first, and then we will be just asking for where the operands are located and so on. So this is the first step, and then instruction operation decoding. So you have to analyze which type of instruction this is, that is whether it is some logical or arithmetic. So it's a arithmetic instruction, you are just want to add the two contents. So analyze the type of instruction, then the address of this operands needs to be calculated. So these two are whether it's referencing to some memory or IO or any other CPU register, that you have to find it out. And then operand fetch. This operand fetch operation is from the memory or read write, which is concerned in this case. Fetching means definitely you have to read it from this. So whether you are reading it from memory or reading it from IO, that you have to find. But fetching means you are reading the instruction. Okay, perform the operation, you are doing the addition. Here in the previous example you are doing the addition and you are writing the result into some memory or IO. So previous case it is all about memory, there was no concept of IO, like in this b add b comma a, that instruction we have. So that is the that is all for today. Thank you. So this is the different types of cycles that is important in the instruction fetch, decode and operate. Okay, different types of things. Thank you all.